Alrighty, welcome back to another episode of Learning with Lung. And by request from some of the Year 10s is a video on completing the square. So we're just going to do a couple of examples, hopefully to help you see my thought process. I'll lay it all out and we'll go from there. All right, so firstly, before we complete the square, we need to just remind ourselves what is a perfect square? Or what do we mean by completing the square? And in order to do that, we have to understand a very fundamental idea, that is this idea of a binomial expansion. This is where we expand a bracket, which typically looks like this, where x plus a, where a can be any number. And we know if we expand these brackets, this becomes x squared plus ax plus another ax plus a squared. But then we know we can combine like terms, so we get x squared plus 2ax plus a squared. And what we notice with a perfect square is we notice two things. Firstly, we notice that a appears in two places, right? A appears in this second term here, and it appears in this third term. In the second term, this one, we notice that a is getting multiplied by 2, and we know that in this term, a is getting squared. The reason why this is important is because this means that we can now isolate a pattern and we can, as we say, complete the square. That is, we can recover or get back this bracket by making sure that this pattern holds. So that's what we do when we complete the square. And what we're going to do is we're really going to rely on this fact right here, that the middle bracket, or not the middle bracket, the middle term can tell us what a is as long as we take the number in front of x and we just divide it by 2. So how does that look in practice? Well, let's do two examples. So firstly, let's just do a very simple example. X squared plus, let's go with 4x plus 1. So I want to complete the square on this thing. Now, the first thing I notice is that it doesn't fit this pattern above, right? That is, there's no a that squares to get 1 and multiplies by 2 to get 4. So what I'm going to do is I'm going to complete the square. When I say complete the square, what I'm doing is I'm not changing the values of this expression. What I'm doing is I'm going to insert numbers so that I can create a perfect square, so that we can get back this thing. So what I'm going to do is firstly, I'm going to just split up my expression a little bit, just to help me see. We're going to throw the 1 on the end. And now we're going to think. We want this thing to be equal to x plus or minus something squared. So how are we going to do that? Well, we're going to exploit this pattern above, the one that I've underlined in green. We know that we can take the number in front of x, divide it by 2, and that will give us a. So let's do that. So let's take the number in front of 2. In this case, that number is 4, or positive 4. So to get a, what we'll do is we'll go with 4, we'll divide it by 2, which gets us 2. And so this means that a is equal to 2. I put a box around this to make sure that I never forget it. This is what's going to end up inside of my bracket, right? Then, in order to make sure that our equation remains the same as the one before, we want to make sure that we get this a squared. But we can't do that by just putting in a squared, because we can't just add anything we like to a bracket or to an expression. We need to make sure that we keep the equation balanced. How do we do that? Well, firstly, we calculate a squared. And what we can do is we can add a squared, or in this case, we can add 4, and we can subtract 4, because this thing just becomes 0, right? So in other words, I've really done nothing. This is equal to 0. But what I've done now is I've created a term that completes my square. What I'm going to do is I'm just going to move this thing a bit lower so we can see. If we look at these first 3 terms now, this is why we say complete the square, not like, well, completing the square is a good name, actually. So completing the square means we've actually made it so that there is a perfect square now in this expression. Yes, there's a bunch of stuff at the end. We don't really care about that. We just care that we've made a perfect square. And what we've done is we've made this perfect square. X plus a, which in our case was 2, squared. And then we can't forget about the stuff at the end. We have a minus 4, and we have a plus 1, right? If we expand that bracket out, guaranteed we'll get those terms, x squared plus 4x plus 4. Which means now we've successfully completed the square. We just simplify, and we're done. Completing the square means that I've created a perfect square. It does not mean that my equation suddenly becomes nice. It does not mean that I can even factorize it. All it does is it means that I've successfully created this perfect square. Yay. Cool. All right, let's do another example. This one we'll do one with it where it gets a little bit trickier because there's odd numbers flying around. So example 2, let's go with x squared plus 7x plus 4. Again, you should be able to verify by eye that this is not a perfect square, so we need to complete the square. Again, completing the square just means that we are going to add and subtract terms that create a perfect square. It does not mean our equation is going to look nice. Okay, it's just a process. So again, let's split it up. We'll throw the 4 on the end, and now we think. We look at this middle number. We know that this thing had to get multiplied by 2 in order to get a. So we can go 7 divided by 2 is equal to, now let's just leave it as a fraction, which means a is equal to 7 over 2. And a squared is equal to, again, squaring fractions is easy. We just square the top and bottom, 49 over 4. Cool. Which means we're going to add this a squared and take it away. And now, because of the way completing the square works, we have guaranteed, this is the really awesome thing about completing the square. If we do it correctly, it guarantees that we've got a perfect square. There's no guessing or checking about it. It guarantees it because we've reversed the process to get a, and then we've just added and subtracted a squared. So we get this, x. This is why I put my a in a box so that I never forget what a is. A very common mistake is that you accidentally put the wrong thing inside the bracket, like you forget to divide it by 2 or whatever. But just putting it in that box means you just never forget what it is. Add 4. And now we'll just do a bit of fraction simplification. So it gets to x plus 7 over 2 squared minus 49 over 4 plus 16 over 4, which simplifies to x plus 7 over 2 squared minus, and then let's just quickly do 49 minus 16, which is 33. And we're done. The square has been completed. We've got a perfect square and we have simplified the rest. Perfect square complete, simplified. And then from here, you could solve the equation for x. You could use difference of perfect squares. But the idea is that completing the square has meant that we have created a perfect square inside of our expression, which is really awesome. Just to finish off, the key reasons for completing the square. The first reason, I think the most important reason, it means x only appears once. Notice before x was appearing twice, which makes it really hard to solve for x. This makes solving easy. Cool. And the other reason why you can complete the square is so that we can apply difference of perfect squares, which really isn't that necessary. Once you've completed the square, you can just solve normally for x. Cool. Hopefully that's helpful for completing the square. Yeah, all the best with your learning.